Okay, welcome back. I thought I'd do a quick video today just on some of my maze lambdas because I've added a few criteria to them, made them a little bit more powerful, so I thought I'd just try them on some cases and show them off a bit of a showcase of the stuff I've built. So the first things I've got is a couple of setup lambdas. So the first is kind of find in map. So a lot of times you want to find where something is in map. So I've got find in map, and then I can find, a tree in this map. And it's going to spill out all the locations where that item exists in the map. All this is doing underneath is a flattened map, which is two-columning the map and the addresses together, and I'm filtering this address column for where my item is here. So that's super useful. I also have address to contents, which a lot of people have, so I can select addresses and a map, and it will show me what's in there. Another setup you also often want to do on maps is to mark colours, because it may be that you can only walk on like a path. So this, say this is a grey path, green grass and some blue water. I might want to copy the map and put the colours over the top. So if I just run that macro there, that will have a number for each different colour, which again most people will have, and most people have seen that, but that's useful to designate where we can walk. And I guess the bulk of my main lambdas that are a bit more complicated are blocking out the map. So I think we've seen that before. To do that, you might want to designate, you'd need to like flag what's blocked and what's not by writing on a copy of the map somewhere. And then I could take some inputs like this, give them a range that they will block you by. So let's say 1, 1, and this bear could see in a square of 4. And then I'd be able to say something like, let's just get the formatting here so we can see it nice and easy. We could say block out map, this map with these blockers. So then we can see the range that everything can see us at, basically. I also have an optional to turn that into anything that I like, so an X only, so that one of the lambdas later I can say don't walk on the X's, and then that allows me to block out all of these without much effort. I can also specify custom directions that these things can see in, so if I enter a list of row column coordinates, then I can specify where these things can see. So I guess the next lambda, that I actually have 2 of them, and these are very similar and cover the bulk of questions. So the questions are normally, how long does it take to get from one place to another? What's the minimum distance you can get there? And you have kind of 2 types of mazes. You either have steps or a cost type. So steps would be, you're given a starting location and each cell is a step, and you have caveats again that you can only walk on the path, you can't walk into any of these blockers or things like that. And then the second one is that each step has a cost. So it might cost 5 to go down, 3 to go across, 7 to go diagonally, and that gives you kind of a non-scaled map. So it might be in Pythagorean scale. You're still doing steps, but the cost is variable depending on the direction you go, and maybe other factors as well. So let's just quickly show those. So the first one is just maze. So I pick a map and pick a start location. So let's just say it was A1 in this example, and that's just going to spill out how long it takes to get to everywhere. And I can also ask for a target. So I could ask for this target being O20, and it would just give me the 19. So let's just show you that quickly. O20, 19. So we've seen a lot of that. I can also add an allow or block condition. So let's say I was only allowed on the path. I could highlight these with a number, which is already done down here, to be fair. So let's just copy that up just to cheat a bit, and then I'll Control Z after. So let's start in A1. Let's say we're allowed on whatever this number is here for that color. Then I'm going to spill the path and how long it takes to get anywhere. The thing I've added to this one that's new from last time is this custom directions bit at the end. So let's say I could only move with some certain arrows. So let's spill some arrows. And let's do arrow to R2ref. So I can specify my custom directions are that I'm only allowed to go in these directions, and that would then give me, I can only actually make it to there, and so on and so on. So these could also be steps in 2. So let's just times them all by 2, for example. And let's now make that my list of custom directions, and I'm only allowed to walk on the path. Okay, so I can only get here. So this is where I can only jump 2 at a time. So I could do night moves, any type of move or jump you can imagine with this lambda. Let's just allow everything for now. So an easy way that I can actually do that, since I have this allow condition, is I can just say disallow something that's not on the map, for example. So I could say disallow the letter A. I know that that's not on the map, so then that will allow me to go everywhere. The problem with this one is when I'm jumping 2 spaces, if I was ever asked how long does it take to get to this cell here, which is blank at the minute, I wouldn't have an answer. So I'd need that to fill with 2 or 2.5 or whatever it is. So that's where kind of the next one comes in. Extremely similar. It's called maze distance. And on this, I can specify an overlay on the map. So let's specify 2 here. I can then say equals maze distance, and the syntax is exactly the same. I take a map and I take a starting cell. So let's say A1. And what that's going to do is it's going to use the distances in these cells for how long it takes to get through each cell rather than just giving me the steps. And this is useful because, again, I've added a very similar argument at the end for a map scale. So it's a slightly different input. I wanted to make it simple for myself, so I just wanted to ask, okay, what's the cost of traveling in each of these cells? Now, as long as I put a number in my map, then as soon as I use this map scale, it will override whatever distance is here and use these distances. So let's say we had, let's say we could move every 2, just like the last example, we had all the gaps in the maps. Well, actually, the cost to move in each direction would therefore be 0.5. It's going to be 1 over that number. So if I just put that in for a second and use this as my map scale argument, and I highlight the whole arrows here, and I'll explain why in a moment. Now I'm going to see the actual distance to get to anywhere, and I could, round up or round down depending on the question. I can also only specify, diagonals. So this allows me to restrict what directions are allowed as well as how much they cost. And also it means I can do things like a Pythagorean scaled map like this, which is in one of the cases which I'll show soon. To disallow areas, all I'd need to do is delete them off of the map, like so. And now the X designates that I can no longer go there. So that was a lot of information, but let's just go through some cases and see how these would be used. So the first case, very simple, Bear Island. We have a map here. These things will block our path, and we want to know in second to last question, is there a bear that has sight of these cells? So this is perfect for that block out map. Lambda, so I can block out this map with these blockers, and then I will spool the map there. Then it's very easy for me to just use the address to contents lambda that I had before on this map, and it will just tell me what bears have sight of these cells. Now this is probably a very easy case for most people, but I'm kind of going to go through all of the maps that I have that have the steps type of map, and then I'm going to get into ones that are more custom directions, which can be a lot more complicated, like Yellow Brick Road. And then the last question on Bear Island was asking how long it takes to get to a location from, or to get from these locations to a plane, which is in E27. So for this one, I can just say maze, here's my map, and I start in E27, and my targets, I can actually spill a whole range here, and that will just give me the answers. Now, in this example, I didn't need to specify what was allowed and what was not allowed, because by default, I've allowed the blanks to be walked on. If I had a different map, like I still had the trees spilled over here, I'd want to eliminate them. So in that case, I'd want to turn these into X's, or any other character, and say X's are disallowed, which means everything else is allowed to be walked on. So that's the first case. Let's find another one with steps and try and build up the difficulty, I guess. Okay, so let's have a quick look at Lana on holiday. So I'm only going to look at the bonus question here, which is concerned about moving around, circumventing the island. So the question is basically how long would it take in steps to circumvent the island only walking on the beach? So let's just set that up. All I would need to do is get my colours over here, and then this number here is going to be the colour I'm allowed to walk on. So let's quickly just set this up in a new tab to make it a little bit cleaner and delete everything out. That's a big map. So we want to pick a start location. So we could pick anywhere, really. Let's pick down here, nice and flat, to go purple. Okay, so we're in AG 48 right now. So let's just mark that down, AG 48. And we basically want to be able to walk on all of these locations. So let's just remove a couple here, and you'll see why in a moment. And I want to say maze, and here's the map. And we're only allowed, we're starting in AG48, targets doesn't matter, we're allowed on whatever that yellow number was. So that will then spill around the map. The reason I cut these ones off here is because this would keep looping, kind of, you could go around infinitely. So that would sort of bug out. So I can see the shortest distance to get back to here from this location was 135. So 136, 137, 138 should be the answer for this question. I haven't done this for a while, so hopefully that's right. And yes, it is. So that just shows how easy it is to kind of use this, this steps one for stuff like this. Okay, so another classic example here. We want to move around this map from two locations, a start and an end location. However, we are not allowed to walk on the brick wall or rattlesnakes. Let's grab a rattlesnake and a brick wall and block those out. So I think they had a range of 2, brick wall has a range of 1. And then I've just blocked off the wall here with an extra brick. So that was previously like this, but I'm going to block it off with a brick because I'm going to actually do this all single cell rather than spilling the blocked out map and show it, just to demonstrate how much more quick this could be. So I'm going to say maze, block out map. Here's the map. Let's lock it. Here's the blockers. Let's lock those. And then my start is given in the question, and my end is given in the question. We're allowed to move diagonally, which is my default. I don't need to say allow, disallow, because that blockout map is going to spill the blanks for me. There's no custom directions to be involved with, and that's just going to give me the right answer straight away. Okay, let's go on to another steps one, but this time a little bit more complicated because you're only allowed certain directions. So here we have a map. I've just marked out water in the blue quickly, and this time we're only allowed certain arrow directions. So let's just quickly XLOOK up our person in here and give me the arrows. And actually my input needs to be the RC references of where we can walk. So let's turn that into RC references quickly. So now I have my RC references. I'm just going to put them 2 row. And my Lambda will take them either in row or column format, it doesn't matter. So now we have the directions everybody can walk in, and they're looking for something on the map. So I know from doing this case that they're all in one location, but if they weren't, I would just use the find in map to calculate it from anywhere. So find in map that, and then my map is this thing here. And I'm going to sort of stop spilling the map out in intermediate steps at this point, just because you've seen that, you have the gist of how it works. I'm just going to build it all kind of in single cell. So this is just a standard steps maze again. There's also a nuance in this question where we actually need to do it twice. We need to go from a start location to an object, and then back from that object to an end location. So let's just get the start bit done. So maze, obviously we have our map here, and let's lock that. And then our next argument is where we're starting. Well, that's actually given in the question. Our targets are going to be find in map this in this map. Let's just lock that again. I always forget to lock cells. And then the diagonals doesn't matter because we're going to specify custom directions. Now for allow and disallow, I'm only going to use the disallow argument. I'm going to say if this is Howard, I think it's Howard, his name, yep, then he's allowed everywhere. So I'm just going to say block out A, because I know that's not on the map, so he'll be able to go everywhere. Otherwise, I'm going to say block out W. And then the last argument is my custom directions, which is going to be this. And that is going to give me the first kind of leg of the journey. We then need to add the second leg of the journey. So I can just do a plus, copy it again, so the maze is the same. This time the start location is actually the object, so it's defined in map formula, and our end location is this. And then we have the same allowed or disallowed, and the same custom directions. So let's just remove that equal sign, and you can see we get the right answer. And that should work for all the questions. I just needed to refresh it. Okay, so that works for all of them. You can hear, I don't know if you can hear my computer fan turn on there, but it's word round. But yeah, that works for all of them. So again, a more complicated and involved example there with custom directions. Okay, so now let's look at some non-scaled examples. So we're not just doing the steps lambda, now we're going to start adding a scale to the map. So let's start with ship the world. So on this one, you needed to calculate the distance from a port here, which is port Excel. E13 is always going to be our start location, and we wanted to go to all of these ports. Now sometimes these canals were open and sometimes they were not, and we needed to make a formula to decide whether that was true, and then count how many times the ships would also go through these canals. So if I was to use the normal maze lambda here, I would specify that the green cells can't be walked on and everything else can, but these can only in certain times. The problem with that is I'm never going to capture when I've gone through these, because there's no distinguishing features to tell me whether I went through a canal or not. So in that case, what I can actually do is if I label everywhere I can go and then get rid of where I can't, that's the quickest way to do this. So I can't actually go on the green, so let's just delete those and then get rid of these edges here. So that's everywhere I can go. But if I change this canal to 0.1, then actually I'll be able to tell when we've gone through a canal. So if I now said maze distance, my map is here. Let's say my start is E13, and let's say I wanted to go to this port over here. So that's V14. Well, that's going to be a cost of 17. Let's just spill the whole map so you can see what I'm doing here. So now that I have something different in the map, this is where this maze distance lambda starts to become quite versatile. So if I'm starting in this cell, I can see at which cells would I have gone through a canal to get there quickest, because I have a 0.1 on the end. And where I have a 0.2 on the end, well then I've gone through 2 canals. So at the end of the question, it would be quite easy to take the, round it up to know how many cells I've been through. Even better, I could have gone 1.1, and then just normal rounding would tell me how long it takes to get everywhere, and the decimal part will tell me how many canals I've gone through. Obviously, if there's more than 10 canals, I'd need to do 0.01 instead of 0.1 or something like that. But it means you can do stuff like this. I won't solve this case because it will take a bit long, but let's start to get into some more examples. So deep sea diving, another one where we had to find distance from a boat to a piece of treasure, but the map was not scaled, which made it really difficult. So let's just quickly copy this into a new tab. And what I can do is, let's just cover everything in a 1 where I can swim. So the boat is also a starting location. So now I can put my map scale in, so I can say arrows. And I know that down, it would tell me in the case was 3, across is 4, and diagonals are 5. So 3, 3, 4, 4, and then these are all 5. So that's the scale of my map. And in the real thing, you had to kind of calculate how you can get from somewhere to somewhere else in the minimum time. And you had to come up with quite a tricky formula to be able to do this. Whereas with this way, I can just say equals maze distance here. And I'm going to start at AI2, AI2, and let's put in my map scale, which is here. And then we're basically done. So I'm just gonna format. I'm just gonna format so we can see what that looks like. So that would then tell us the Pythagorean distance to anywhere. So we could then just ask what's the distance to any treasure piece. So to give you an example of the questions, you know, it's asking what's the distance to the treasure. So let's actually just do it just to show how quick it is. So we want maze distance. Here's our maze that's specified where we can go by adding a number. Just lock it. We're starting at AI2 and our target is here. And then we have a custom map scale in this example, which is here. So that's going to give us, hopefully, the answers there. And again, we could have just spilled this down as well in our targets thing. So we could have actually taken an array here and we'd have got the same thing. So yeah, this makes it super simple. To then find the oxygen, you just times it by 2 and calculate the max depth, and then you just build up that, but it makes it very quick and easy. And obviously I can specify any start location and end location. So later on you're going on a treasure hunt from one treasure to the next. So very easy to then calculate the distances. When I originally did this case, it said that you could go through this sand, which made the case at the time what I thought possible. I was thinking it would be maybe impossible if you couldn't go through the sand, but actually with this method it becomes completely possible because I can just remove those locations and now we can't get there. So it would calculate while avoiding obstacles. So that's one of the what would be a very hard question is if you had a specific map scale but you also had to block out certain objects, and with this combination of lambdas I should now be able to do that. So let's quickly show 2 more examples. So Kansas map, on this one I think I can use either lambda here, but there was 2 hard questions. Basically the first was this one: how long does it take you to get to brick 96? So that is here in M13. So let's just write where we're starting, M13. So we could actually use the first one and just do, let's put some arrows in here. So on this map, we can go in all 4 diagonals, those are fine. We can go left and right, but up and down, not really. We only care about going diagonally to move to a brick, or 2 across. So to go across, we actually just times this by 2. So that's the moves we are allowed to make. So then we can find these bricks. So let's just quickly set this up. So if I just say flatten this, actually I can use my find in map thing. So let's say find in map this object in this map. That's going to then show where we are. And then I can say maze, here's our map. And we are starting in M13. We're ending here. Let's block a letter that's not there, so we're allowed on everything, essentially. And then our custom directions are actually these. And that gives us our answer for a question like that, which at the time was extremely tricky to calculate the distances. You had to really think about what's the calculation for this. Whereas with this method, I don't really need to think about a calculation. I just need to put in, you know, what does each movement cost? What's the allowed movements? Again, I could also do this with the map scale one by saying, as you saw before, I could just put the arrows in, and I could say across is a cost of 2. Actually, I could say across is a cost of 0.5. 0.5, 1, 1, 1, 1. So I could put in that array into the maze distance 1 as long as I overlaid a number into every cell. The merging would mess you up a bit there, so you'd want to copy this out into a new tab, unmerge it and put a 1 everywhere, and then the other method would work. You could also use it for the next question, so you had a starting brick and you wanted to know what's the minimum brick 3 cells away. Well, because I can spill the whole map, let's just do an example for the first one. I can say find in map here in this yellow brick road. So we're at D6, I want to know what's 3 cells away. So I can say maze, here's the map, and we are starting in D6, and don't worry about the targets, let's block anything that's not there, so that i.e. we're allowed on everything. And again, our custom directions are these, and let's just delete this, and then what we can see is the whole yellow brick road map spilled out of how far everything is. So all I need to do is filter this for where it's less than 3. So I can say if that is less than or equal to 3, give me what's in the yellow brick road. Let's say give me blank otherwise. So then I can see what's within 6 cells, and I can just take the what's within 3 cells and just take the minimum of them. So yeah, it's super powerful. Another trickier example is this Temple of the Golden Idol here. So we had a spilled map with kind of terrains going through them, and each terrain had a cost. So and each animal would go through terrains at different speeds. So we had this table up here. So what we could actually do, let's just take an example here on Temple 2, it's a bit bigger. Nobody really got through this case, it was tough. But with this method you can just say, let's TLOOKUP, which is an index match, this table. And our row item is going to be the animal, and our column item could just be this entire map here, for example. And what that will do is it will spill the map with all of the costs for everything. So all I would then need to do is use my maze distance lambda, because I've already got the numbers now spilled into cells for the cost. That's my map, and my start would be here, it's given to me. We couldn't move diagonally in this, so let's add that argument, and that should be it. So that's basically going to tell me the cost for everything. I could then just say, you know, what's the max in this example here, so maximum of that will give me the number that where we've gone to, and that should just, whoops, solve the question there. And I could essentially just do that for every temple to find out how long it took to get everywhere. There was a case that came out recently, a free case called Tree Climber. So let's just find that, which was really hard. So essentially we had these trees here, and you could walk along the ground and climb up the stems, so the brown bits of the trees. And we had a different cost for whether you're climbing. So here, this is a non-scaled map again, and luckily it's in the exact format that my Lambda takes. So I could just specify, okay, here's the cost of travel, how long does it take to get to any of the goals. So that helped me solve this one. So yeah, that's it. This was just a little showcase of all of the like map lambdas I've got now. I know that Bo and other people have a more advanced version of this, even more so than what I've got, which is crazy. But this is the syntax that I understand and is quite simple for me, so that's what I've got. Anyway, hope you enjoyed. Random video here, but maybe it'll be useful to someone. Thank you.